Okay. Okay, so we are able to, I can hear someone who responded. That's great. Who responded a few moments ago?
Sir, I did. Arav.
Arav. Hello, Arav. Can you hear me? Yeah, I think you
Yes,
can.
sir.
Okay, that's great. All right, so we have many people joining in right now. So in the meantime, can someone remind us that what we did in the last session? Uh,
Sir, we did geometric.
we did geometric transformations, isn't it?
Yes, sir.
Yeah,
Sir, the bridge problem.
the bridge problem, isn't it? It's a very beautiful problem indeed. So let's see, we have chats coming in. Okay, maybe I can put this up here. Okay. Okay, so we are almost there. Let me send out another one. Okay. Okay. All right. So we have more people coming in. That's great. And today we have some beautiful plans. I mean, at least I want to do um this is a very nice problem that came up, and very recently in one of the entrances of uh, ISI, Indian Statistical Institute, and we were solving those problems yesterday. And this problem sort of came up, very beautiful problem. It is actually from a book called Lines and Curves. It's written by a Russian mathematician known as Vasiliev, and this was uh, from Russian. It was translated into um English by, I think, Onjon Kundu. He is from Indian Statistical Institute. So I'm sorry, he's from SINP, that is Shah Institute of Nuclear Physics. So if you can open up your videos as well, so that we can all communicate nicely. If you want, we can do that. And also you can unmute your audio as well when you want to speak. So this will be like a math circle, So we can do a beautiful problem today. Okay, so the problem that we want to do today, and this one is, as I mentioned, came up in this year's ISI entrance. You all can do this problem. This is a second type of geometry problem that often comes up in Maths Olympiad as well. So the first type that we talked about was related to geometric transformations. If you remember, and if you were in the last class, the first thing that we did was something called geometric transformation. And what was geometric transformation? It's very simple. It is a way to move around points. It is a way to move around points on the plane. Of course, if you are doing two-dimensional geometry. If you are doing three-dimensional geometry, then it's a way to move around points on the space, on the three-dimensional space. So there are some rules of moving these points, and these rules are known as geometric transformations. Now, on the other hand, we want to talk about locus problems. Locus is the path traced out by a moving point. It's very closely related. You see, most of geometry is about this. You move around points and you try to understand how that happens. You move around points and you try to understand how that happens. And you try to find out some patterns in that movement. And then you also look at paths traced out by the moving point. Paths traced out by the moving point. So today's problem, the one that we will be doing today, involves the second type, that is the locus. So the second type, that is the locus problems, we will be involved with that. So here is the problem. Suppose, and after I talk to you about the problem, I'll give you a way to think about the solution as well. Okay. So this is what we have. We have this, you can think about this, well, as I mentioned a few moments ago, locus is the path traced out by a moving point. Locus is the path traced out by a moving point. So I'll give you examples very soon, but first let's look at this one. So in this problem, we have this horizontal line, which is known as the x-axis. We often call the horizontal line as the x-axis. And then we have the vertical line. We have the vertical line, which is the y-axis. So we have the horizontal line, which is the x-axis. If you have not seen this before, that's fine. Just imagine two lines. One is perpendicular to the other, like this. Okay. So that's the vertical line and the horizontal line. All you just need this much. You don't need more than that. Now suppose there is a line segment AB. There is a line segment AB which is sliding along the x-axis. So it was standing erect in the beginning, like this. Okay, so this is A1, B1. This is the initial position of this line segment. It was standing erect. It was A1, B1. Now it is sort of moving like this until it gets flat. Okay, do all of you see what I'm saying? Do all of you understand what's happening to AB? You have a line which is standing erect, and then you sort of slide along. B is sliding along x-axis and A is moving down y-axis. That's what's happening to AB. Okay, great. Now there is the midpoint of AB, which is the point C. That's the midpoint of AB. So let me write that. C is the midpoint of AB. C is the midpoint of AB. Okay, now there is a line that is perpendicular to AB at the point C. Suppose this is P. There is a line that is perpendicular to AB at the point C. So PC is perpendicular to AB, at the point C. That's also given. C is the midpoint, PC is perpendicular to AB. So all of you draw the diagram while you are watching this. You should have a pen and paper, and you should also draw the diagram. Okay? Okay, there is one more information that is given to you. The length of AB is 20 and the length of PC is 10. The length of AB is 20 and the length of PC is 10. Okay? Do all of you see this? Great. Now the question is, what happens to the point P? What happens to the point P as AB is moving and it's sliding from the vertical position to the horizontal position? What is the locus? What is the path traced out by the point P as AB is moving from the vertical position to the horizontal position? What happens? That's the question. So all of you draw a picture and give a try to find out, and you can guess. You can put your guesses in the, like, you can either in the comments, or you can put your guesses in voice, like you can speak up. What do you think should be the locus of the point P as AB moves like it's moving right now? What should yeah, go ahead.
C will move like in an arc of a circle, and P will also move in an arc of the circle. C will move in an arc of a bigger circle, and P will move in a smaller circle.
So I see what you're saying. I see what you're saying, but you are right that C is moving in a smaller circle. That is right. But you have to work a bit harder with P. I can assure you, P is not moving in a circle. Think a little bit more. So what he said right now
P
is
is
this.
still.
Sorry?
Sir, P doesn't move because like it is acting as a radius, so I think P does not changes its position.
So maybe what he's saying is P is a stationary point.
Yes.
Not really, but that's a good guess. P is not a stationary point. So I had two guesses up to now. Number one is that P is also tracing out a circle, and number two, P is not moving at all. So both of these guesses are not right. But
Sir, P is downwards a bit.
Okay. Think a little bit more.
Sir,
something
I have
like
one more
this.
guess.
Sorry?
Sir, I have one more guess that like the locus of the P is a straight line. Like I'm taking some of the small cases.
This is a good guess. You're right. The locus of the point P will be a straight line. That is correct. Very good. Think about a little bit more. How can you actually show it? It's not a straight line actually. It'll be a bit different than that.
Sir, I think it will be like this. I'm showing it in my video.
Not exactly. So let me do one thing. Can all of you see the GeoGebra board that I'm sharing with you?
Yes, sir.
Yes.
Okay. So what I'll do is I will be drawing I'll try to do an animation of this particular thing. And there is some mathematics involved in it. So you can actually yourself do this. So this is okay. So this is how we'll go. Sorry.
Hello, sir. I am Shorodip.
Yes, Shorodip, go ahead.
Uh, I think that P will move in a straight line.
P will move in a straight line. Okay, that is actually right. As I said a few moments ago, it's absolutely right.
Oh, okay.
P is a straight line. But what type of straight line is it? That's the question.
Mm.
So we have to think a little bit more about it. You have to think a little bit more about it. So maybe I can put this. So let me do one thing. So this is how this is the look. This is how B is moving, and I want A to move as well, like this. So simultaneously AB will be moving, keeping the length of AB fixed. So how are you going to do that? Well, we will be putting the, so let's do one thing. Let's put this thing a little bit down.
It's a vertical straight line.
Let's put it like this. Yeah, sure. So the first position that we are going to use is like this. We will be taking the midpoint. So let's take the midpoint of AB, and that's C, as I mentioned. And let's draw a line segment that is perpendicular to AB through C. Okay, do all of you see this? I have drawn AB and I have drawn through C, the midpoint, a perpendicular line. Now I want to draw a point on this perpendicular line that is equal to 10. If AB is 20, that is half of AB. I want to find out P. P is exactly half of AB. So can anyone tell me, how do I construct the point P from this picture?
Sir,
Yeah.
Sir, draw a circle.
sir, take the CB radius
Yes.
to coincide with the line which is perpendicular.
Perfect. So let's do that. So we have this circle. Excellent. So this is the point right here, which is the point P. So this has come out to be D. So I can just rename it to BP. Okay, great. So this is P. And now I can forget about the circle. I don't need the circle actually. I can forget about the line as well. And I can just draw the segment. Right. Here we go. Okay. So this is one position of the point P. Now the question is, okay, maybe I can just move it a little bit closer. Okay. Here we go. Now, so some of you have said that this is a straight line. The locus of the point P is a straight line. It's actually more than that. It is something called a double cover of a line segment. So if any of you are in college, or maybe if you've seen a little bit of complex numbers, you have seen the word double cover. So what is double cover? Double cover is simply revisiting a point 2 times. So imagine you're moving like this and you're moving back. You're moving like this and you're moving back. You are visiting a same point more than once. That is known as double cover. You're just not drawing a segment. You're sort of drawing from one end to another and then coming back. In the process, you are visiting every point how many times? 2 times. Right?
2 times.
So that's why I call it a double cover. Anyway, we will see why this is a double cover in a moment. But first, notice what's going on here. Let's mark the point O. Let's mark the point O, which is the origin or the center, maybe. And this is again giving us, okay, it's naming it as D, whatever. So this is O. And we will be joining PA and PB and PO and OC. So I would ask you to draw this picture with me. Please draw this picture with me in your notebook as well. It's a very beautiful picture. A lot of things are happening here in this picture. But let's keep our focus on what's important. You see, can anyone tell me the relationship of C with AB? What is the relation of C with AB? Can anyone remembers it?
So the midpoint.
It's a midpoint.
It is the midpoint.
It's a midpoint.
It's the midpoint. Very good. What type of triangle is triangle AOB? It is a very beautiful type of triangle.
A right angle triangle.
It is a right angle triangle, isn't it? So what can you tell me about the point C, the relation of the point C with the triangle AOB? This is a very, very...
circle center.
Who said
So
that?
it looks like...
Is it Onik Kumar?
Yes, sir.
Okay, Onik, that's excellent. Very good. It's true. C is the circle. So this is one of the most important tools in geometry, in pre-college geometry. That, I mean, it's surprisingly simple, but it's very, very useful. That midpoint of the hypotenuse of a right angle triangle is the circumcenter of the right triangle. You can prove this. I can give you, I mean, I'm sort of giving you a thing to, I mean, you can rigorously prove this. So if I take this, I move up to A, you see that circle is, okay, this is kind of weird. The circle is passing through A or B, but it is also passing through the point P. Do all of you see that?
Yes.
It is not an accident. Why not? Because what do we know about the length of PC? What is it that we know about the length of PC?
So
It is
PC
the
is
radius.
same as CA and CB.
Exactly, it's half
Because
of
it's
AB.
10.
PC is exactly half of AB, right? If you have AB, PC is half of that. If AB is 20, PC is 10, right? Great. So P, so okay, you have to think of this in a very different way. Think about it like this. Imagine like this. P is a point which is equidistant from C as the distance of A, as is the distance of B, as is the distance of O. So C is like the center. P is equidistant from C as with A, as with B, as with O. Do all of you see this?
Yes.
Yeah. So this
Yes,
is,
sir.
you see, this actually is a, I mean, it's the same thing. I'm saying the same thing, but it is really thinking of the point C and the point P and the point A, O, B in a different way. Okay, now let's see what we can say about this angle ABO. What do we know about it? So maybe I can mark it. Angle, oops, sorry. Angle ABO. Okay, this is giving me the data. I don't need the data. Okay, so whatever this green angle is, what do we know about it? Can anyone tell me? What do we know about the green angle? Well, okay, fine. Can you tell me what angle is the green angle equal to? The green angle is
This
equal.
is equal to COB.
The green angle is equal to angle COB. Absolutely. Why is that?
Because
Sir,
this is
because-
isosceles triangle.
Yes, sir.
Because OC is equal to BC.
This is isosceles triangle. Okay, great. So that's correct. Maybe I can zoom out a little bit. It's zoomed in too much. So maybe like this. Okay, here we go. Okay, so now let's mark that. C O. Okay, maybe not. B O C. So these two angles are definitely equal. Okay, that's great. You see, I have joined OP as well. I want to find out the value of angle POB. I want to find out the value of angle POB. So maybe I can use a pen. And where is it? Here we go. I want to find out the value of this angle. So if this green angle is theta, if this green angle is theta, can anyone give me the value of the black angle? If this green angle is theta, can you give me the value of the black angle? Use some sort of angle chasing to find that out. Give it a try, all of you. Spandan, I just said that assume that the green angle, give the green angle some name. Suppose it's theta. Can you, using the green angle, can you, using that theta, find out the value of the black angle, this one, right here? Give it a try. Try to find out the black angle, all of you. You can do some sort of an angle chasing to do that. Okay, so if this one is theta, can anyone tell me what is the value of this angle right here? This one is not hard.
Sir, 180, sir?
Yeah. Yeah, you are right. You were saying the right thing actually.
So it will be 90, I think so.
Okay, can you tell me what angle is this maybe? This one is easier.
Sir, it is 180 minus
180
2
minus
theta.
180 minus 2 theta.
180 minus 2 theta, right? Great.
Sir, then OCA will be 2 theta. OCA.
Okay, OCA is 2 theta. So this is 2 theta. Okay.
Sir, I didn't understand why this should be 180 minus 2 theta.
Okay, because this green angle is theta, right?
Yes, sir. Yes, sir. Okay.
And the three angles of a triangle adds up to 180 degree. So
Yes, sir.
this one is 180 minus 2 theta. Great. So 180 minus theta, and we have 2 thetas there. Okay. So this is 2 theta. What is the value of this angle? Angle PCA.
180 minus 2 theta again.
What is this? Is PCA? This black shaded angle.
90 degree.
That's 90 degree, right? PC was perpendicular.
Yeah.
Yes, sir.
Okay. Now, can you tell me the value of this little angle? There is one more isosceles triangle in this picture, and you should be able.
45 minus theta.
Okay, is it 45 minus theta?
Sir, triangle ACP is an isosceles, I think.
ACP is isosceles. Okay, But we need
Sir,
a different type of isosceles.
COP is isosceles.
COP is isosceles.
COP is isosceles.
Excellent, excellent. You're right. Why? Because OC is equal to PC, right? Because both of them are half of AB. PC is half of AB because that's given. If a PC is 10, right? If AB is 20, PC is 10, and OC is equal to half of AB because C is the circumcenter. Okay, so
So angle POB is 45 degrees.
angle, which one? Sorry,
Angle POB.
POB is 45. That is what we will be getting exactly. So these two are equal, which means this check mark angles will be equal.
Yes,
Okay.
sir. So it will be 180 minus, 180 minus 90 plus 2 theta by 2.
180 minus 90 minus 2 theta actually, because 90 plus 2 theta you're
I
subtracting.
told in brackets.
Yeah, bracket, you're right. So this divided by 2.
Yes, sir.
That's the value of the check mark angles, because 180 is the total angle, and this angle right here is 90 minus 2 theta. So that you subtract 90 plus 2 theta, that you subtract, so you get this. So you get 45 minus theta, right?
Yeah.
Yes, sir.
45 minus theta. So this, if check mark angle is 45 minus theta, then you know what you have here, right? If the check mark
45
angle,
minus theta plus
45
theta is,
yeah, so that is 45 minus theta plus theta.
plus theta.
45.
That's 45 degree. So we have found it. You see, whatever is the position of the point P, OP is always making 45 degree with x-axis. That's what we found, right? We did not put any restriction on the position of AB. Did we put any restrictions on the position of AB? We did not. So whatever
sir.
may be the position of AB, whatever may be the position of AB, OP is always making an angle 45 degree with AB. Now, how can that happen? That can only happen if P is on a straight line. P is on a straight line that is making an angle 45 degree with AB. Imagine from the point O, imagine a ray going out which is making an angle 45 degree with the x-axis. What this is saying is P always stays on that line. P always stays on that line. The ray that is making an angle 45 degree with x-axis, P always stays on that line. That's what this is saying. But we are not done. Many students will stop here and say, okay, maybe that's a straight line. But it's quite not that. You see, you have to also realize that if the position of AB, so I can go back to the earlier picture that I had, if the position of AB, okay, here we go. Where is it? Okay, so here we go. So maybe I can find it here. Okay, so if the, I'll change this. So if this is the situation, if the position of
Sir, I can't see the screen.
yeah,
Sir, it's white.
just a second, I just change it to whiteboard actually. Okay, I think now you will be able to see it. Okay. So now you can see it. See the screen again. And can you see me drawing on the screen?
Yes, sir. Yes.
Okay. Okay. So this is the thing. So what do we have? We have these x-axis and y-axis, and we have the two extreme scenarios when AB is standing upside down, that is standing erect, and the other one is when AB is lying on the ground. So length of AB is always 20. So in the red situation, we take the midpoint, which is C, and we take a perpendicular, which is also 10 units long. So this is P. So this is 10. So we go, this is 10 and this is 10. So we go up 10, right 10. In the horizontal situation, we go to the midpoint of this, which is C, which is 10, and we go up 10 again. So this particular point P is 10, 10. This is a way of saying how to get there from the origin. You can go either right 10 units and up 10 units, or you can go up 10 units and right 10 units, whatever. So the thing is, the point P is visited, this particular position is visited 2 times. Once it is visited when AB is standing upright. It is visited again when AB is standing horizontally or lying horizontally. That's why I was saying that this is a double cover. It's either standing upright or it's going in the horizontal situation. In both of the cases, the final point is P. So P is visited twice. This particular position of P is visited twice. And what is the other
Sir?
extremum? Yeah, go ahead.
Sir, so we can say that it starts from that point is at P, it goes somewhere and again comes to C at the end.
So it's sort of, yeah, exactly. So it sort of goes like this up to a certain distance, and then it comes back to, along the same path, it comes back to the point P. That's why I was saying this is a double cover. So now it's a double cover, except perhaps for a single point. So can you tell me which point it is not visiting twice? And if you know a little bit of coordinate, can you tell me the other point that it is visiting, the two ends of the segment? And can you tell me why it will be restricted to that segment only? So this is a very interesting homework. You can always use this to practice a little bit of mathematics. Another session is coming up at 8 p.m. This is for people above 9, class 9. But even before class 9, people can attend. We will be discussing some exciting mathematics. Up to then, if you have not registered for the Bose Olympiad, you should go to chinta.com and do it. If you are an internal student of Chinta, keep on attending the PRMO seminars that are going on, because the PRMO has been shifted to IOQM. It's in January, so you all have a very good chance to try it. I mean, that's coming up pretty soon. I'll see you in a bit, in 20 minutes, in the next one. Okay, thank you, and I'll see you next week as well.